Could 2 plus 2 equal 5? And if so, what would it mean in our day-to-day life? Well, let's imagine that I have 2 carrots in my left hand and 2 carrots in my right hand, and I put them into the fridge and I close the door. And when I open the door, I take 5 carrots back from the fridge. Now I put 1 carrot aside and I have again 2 carrots in my left hand and 2 carrots in my right hand. And I put again them into the fridge. And when I open the door again, as expected, I get back again 5 carrots. And since we have kept 1 carrot aside previously, we have now a total of 6 carrots. So essentially, our fridge is behaving like a calculator, which defines an addition in a way that 2 plus 2 equals 5. So we have created ourselves an unlimited supply of carrots. How cool is that? This thought experiment with carrots may sound absurd because it contradicts how we perceive physical reality. But let's not forget that 2 plus 2 comes from algebra, which is part of mathematics, and it deals with numbers and operations such as addition but also multiplication. But we also have geometry, which is likewise part of mathematics, and geometry deals with spatial representation. And we know that there are alternative geometries. On the one hand, we have a Euclidean geometry, which describes behavior on a flat surface, like this whiteboard, where parallel lines do not cross, like this. But on the other hand, we have a non-Euclidean geometry, which describes behavior on the surface of a sphere, or on the surface of our planet, the Earth, where parallel lines do in fact cross. In fact, they cross twice on each pole. So if there are alternative geometries, then there must be alternative algebras. Also the one where 2 plus 2 equals 5. We just need to find it. Defining an alternative algebra requires more than just hard-coding a few values in a programming language of our choice. For example, here we have a Python snippet, and we can see that the code that this snippet indeed produces a desired result 2 plus 2 equals 5. But it actually violates all rules of algebra, all rules of mathematics. For a start, it would also return 5 when adding 2 and 3. So on the one hand, we have 2 plus 3 equals 5, and on the other hand, we have 2 plus 2 equals 5. But that would imply that 2 equals 3, which is nonsense. Also, the addition must be associative. That means the grouping of arguments and parentheses do not matter. That is, 2 plus 2 in parentheses plus 1 should equal 2 plus 2 plus 1 in parentheses. However, we see that they are not equal. So we need to define it properly. Let's check this formula. We can prove that it satisfies associative rule, and it is also commutative, meaning a plus b equals b plus a. However, there is one problem. If either a or b is minus 4, then no matter the value of the other argument, the result would be minus 4. That is, a plus minus 4 would always be minus 4 regardless of the value of a. And this is called an absorbing element, which is perfectly fine in case of multiplication, because in case of multiplication, the absorbing element would be 0, so a times 0 would be 0 no matter the value of a. But this is not expected in the case of addition. Fortunately, there is a formula that works, and it uses logarithms. So we can see here that a plus b is defined by logarithms, and we can also see that we have a definition of multiplication, which basically is an addition of normal numbers, but we'll cover that later. The important thing is that this is a full valid algebra with 2 operations, multiplication and addition, something that you would have also expect from a normal conventional algebra. And we can prove that addition is commutative and associative, and that it is also distributive over multiplication, meaning that A times B plus C equals A times B plus A times C, meaning that multiplication and addition work together. So this is a coherent and valid mathematics. And most importantly, 2 plus 2 equals 5.01 in this mathematics, so almost 5. This algebra with two operations of addition and multiplication defined as we have just seen has a real use case. It is used in decibels. If you, like me, who has a problem falling asleep either because of my neighbors or because of the pets, then you might be familiar with this. These are earplugs, and sometimes they come with an indication in decibel of the sound level that they can reduce. So decibels is used, among other things, to describe sound level, or more precisely, sound pressure level. So how come that 2 plus 2 decibels gives us 5 decibels? Well, in order to answer this, we need to revisit the decibel scale. So it goes from 0 to 194 decibels as follows. So 10 is breathing, 20 is whispering, 75 is an alarm clock, 105 is motorcycle, 140 is a jet sound, and 195 is the maximum level for sound waves. This scale makes sense, except that the physical reality looks different and is measured by the sound pressure level in pascals, with 0 decibel being equivalent to 0.402 pascals and 194 decibels being equivalent to 100,237 pascals. So this scale is huge. The ratio between the lowest value on the scale and the highest level of the scale is more than 5 billion times. So that's why we compress the scale using decibels to the scale between 0 and 194 decibels. And with the scale transformation, the rules of mathematics change, and we are entering a whole new terrain of possibilities. Consider two sources of sound. In my case, my two cats who decide to meow in the middle of the night, each meowing at 70 decibels. So we have 70 plus 70 equals 73 decibels according to the rules of addition of decibels that we have seen previously, which use logarithms. In terms of sound pressure, the pressure has indeed increased twofold, but the increase in decibels is only 3 decibels. Back to earplugs. If my cats meow together at 73 decibels and I use earplugs with the noise reduction of 40 decibels, then the remaining sound can be calculated as multiplication, which is equivalent to addition of values. That is, 73 decibels times minus 40 decibels equals 73 minus 40 equals 33 decibels. Much better. If I then also close the door to my room, that would reduce the noise by further 10 decibels. But if my cats have discovered my microphone, that would give them amplification by 30 decibels. So we calculate as follows. 73 times minus 40 times minus 10 times 30 equals 73 minus 40 minus 10 plus 30. And we have the remaining sound of 53 decibels. This algebra of decibels is called logarithmic Semmering, or log Semmering for short. And it is the same type of algebra also used in case of LLMs, when we want to assess how confident is an LLM in its response. And one of its useful properties, as we have just seen, in case of the earplugs, the door, and the microphone, is that the multiplication of values in the logarithmic space is equivalent of adding values.